Hey, welcome back for another Trick Tip Tuesday. And for today's tip, I'm going to talk about some tips on TIG welding sheet metal together. So before that, I want to remind you guys, if you have some ideas on some things you'd like to see on these Trick Tip videos, send us an email at tips@Trick-Tools.com, and we'll see what we can do to get those included in this series as we bring them to you every week. So like I said, for this week's tip, I'm going to talk about sheet metal, TIG welding it. So I've got two pieces of 18 gauge here, and I'm going to clamp them to the table here, kind of hanging off, just for the example sake of this. Now, you know, some of these tips, obviously, they should be able to be applied to pretty much any kind of sheet metal TIG welding that you're going to be doing. As far as steel is concerned, some things are the same between aluminum, stainless, that sort of thing, but obviously, depending on what material, there might be slightly different welding practices. So for these pieces of 18 gauge steel here, wiped them off just to get any oil or dirt off of them. Now, a couple things you need to remember when you're TIG welding sheet metal is to know obviously what the alloy is. This is just regular mild steel. From there, you want to make sure you know the thickness of it and about where you need your machine set to be able to get the proper heat for proper penetration without getting too much to where you might burn holes through it and that sort of thing. So basically, as an experienced TIG welder, I like to set my machine just a little bit hotter than what is absolutely necessary to be able to weld the sheet metal together. And that's because I like to have that little bit of the ability to go a little bit hotter if I want it, here and there, because depending on what you're welding, where you're welding it, if it's on a car, that sort of thing, sometimes you want to be able to have that extra heat adjustment. So I've got my machine, which is a Miller Synchrowave 210, just an air-cooled TIG welder, kind of a similar unit that you can find in a lot of home shops or professional shops. So I use this welder every day, almost to weld everything that I've got to do. So. But as far as the components of the TIG welder, I've got the machine set at 60 amps. It really only takes 40 to 45 amps really to TIG, let's say this 18 gauge steel. That can kind of vary, like I said, and it might not even need that full 40 to 45 depending on the situation. But for here, I just have a gas lens on here because that's pretty much what I use on everything, is a gas lens inside the cup here. But I'm running a 3/32 tungsten. Some guys will tell you to run a 16th tungsten, that sort of thing. I pretty much weld everything with a 3/32 when it comes to thinner material like this, even up to a little bit thicker stuff. The only time I really change tungsten size is if I was going to be welding super hot, which is pretty much beyond the capabilities of this specific TIG welder. I mean, I can go up to 210 amps, but really, I like to have the machine to where I don't really have to change the tungsten. So I can use the 3/32 for just about everything, so I do. And so really, when it comes down to TIGging the panels, I'm just going to put a clamp on this just to keep these panels level with each other. You might hear different schools of thought, people telling you gotta get it tacked together and then you got to weld, pretend this is a long panel. You'd have to weld a little stitch here, a little stitch here, a little stitch here, a little stitch there, and bounce all around the panel and come back and bounce all around again. I don't like that because what I've found in my experience is that if you weld a little section here, a little section here, a little section here, a little section there, everywhere you weld, the panel shrinks. So you're going to get a shrink, a shrink, a shrink, a shrink. And it's going to end up, by the time you weld all those different spots, you have all these little spots that individually shrink separately of each other, and you end up with little waves in the panel that you have to work out. So typically when I'm TIGging sheet metal, I like to TIG in a straight line. I don't bounce around at all. You're going to get different people that tell you different things, but in my experience, it actually warps more, and you have to work it harder to get all the warpage out of it if you've bounced around. So now, as far as gap in the panel, I'm always set up at 0 gap as best I can to get the panels touching each other that's what you want, is no gap, because the more gap you have, the more the panel is going to shrink. So if you know, let's say you're cutting a patch into a fender and you have a 1/16 gap all the way around your patch and you get it tacked in, you're going to have that, you have that 1/16 of airspace in there that you need to fill with enough rod so that it would hopefully shrink less, which makes your weld bigger. Or if you're, when you're just dropping your rod in there and it's shrinking, there's that open space in there that the panel can then pull in there when you've got all that molten metal together. So like I said, I try to get it to where there's zero gap, and that makes and keeps the shrinking and warpage down. So from there, typically I like to tack weld my panels together. You know, say you've got a large patch that you're welding in a fender, quarter panel, roof skin, that sort of thing. I'll get it tacked about every, first I'll go around and do about every inch. So every inch on the panel, I put a little tack, and I'll do that all around. And then I'll usually come back in and depending on the panel location and all that sort of thing, I'll do every ½ inch in between those tacks, just to make sure everything's really solid. Because then what you can do after the fact too is, once you get those tacks done, they should be pretty flat, and then you can take a hammer and dolly and hammer those more flat. So from there, to actually do the tacking, gotta grab some rod. But so from there, I'm just gonna go ahead and place a tack. So I've got a tack here, and I don't actually go around and measure. When I say about every inch, it's more of a visual thing. I don't go around and measure it all out to make sure I'm exactly an inch, anything like that. So typically just kind of eyeball that 1 inch. Get it tacked. Now on a piece like this, obviously I'm just welding this on the bench, but once I get those tacks in there, I'll usually come back with a hammer and dolly. And just tap them just to make sure that the panels, you know, if there's any difference in the panels as far as the height on that butt weld seam, you know, just you tap it with a hammer and dolly like that, it usually verifies that your panels are nice and level with each other. So again, I had the machine set at 60 amps, but if I was to just go full pedal down on this, it would be too hot. You know, so part of TIG welding in any form is being able to watch your weld, watch how much heat you're putting into it with your foot pedal. So this is no different. So obviously you ease into the heat. Once it starts melting and you get to that point, obviously there's, you know, get your tack done and get out of there. There's no reason to hang out. So so then from there, these ones I'm just going to leave every inch. So essentially when I go to weld this, I will pretty much go in a straight line without stopping, because I found that, like I said before, if you do a stitch, do a stitch, do a stitch, do a stitch, as long as you're keeping steady movement and you're moving and you're not keeping the heat in the one place too long, the shrinkage and the warpage in your part will be more uniform if you can start and just keep going through it. It'll pull it all at the same kind of force, for lack of a better term. So it tends to be more uniform that way, and then when you go to hammer it out, you don't have the individual little warpage and shrinkage from doing a stitch and a stitch and a stitch and a stitch. So go ahead and weld this up. So once you get that puddle going, I just try to keep a nice steady movement. So, and depending on how big the panel is, how long your welds are, you know, and really how good the fit up of your panel is, will all determine how long I will weld. So if I get a part that's, you know, lays in there really nice, the panel's not loaded in place, anything like that, I'll go ahead and weld up the whole thing without really stopping. I'll just keep going as much as I can. I might have to stop to readjust and move, but I won't stop and let it cool for an hour just to come back and do that, like you hear from some people. So, and that's mainly because this keeps, like I said, it keeps all the shrinkage and warpage more uniform in your part. So basically, you know, these were two flat pieces, and this is why I've said that anytime you weld sheet metal and if you bounce around, you weld, you bounce around your panel until you get it all welded up, it's all going to shrink in these different areas. I just did this about a 4-inch weld, and these were totally flat, and you can see the panel now has a little bit of bow and warpage to it. But you know, we got nice penetration on the backside, nice consistent heat trail, and basically from there, this would be pretty easy to hammer and dolly out. I'm not going to sit here and sand all the weld down and hammer and dolly it all out, but you know, if I was to sit here and I'd weld a stitch and then weld a stitch and weld a stitch, you would see the shrinkage here, the shrinkage here, the shrinkage here, and you would see these little waves in the part. So these are tips that I've used and found out through my own trial and error over the years of TIG welding sheet metal, and really spending a lot of time learning what causes more warpage, what causes less warpage when you're welding it, that sort of thing. No matter what, anytime you weld sheet metal, anytime you weld any metal, it's going to shrink. That's just the nature of melting the metal and joining it together. It shrinks up as it cools. So anytime you do that, it's going to move. So you're never going to find a situation where you can weld especially sheet metal, you're never going to find a situation where you weld that panel in and it doesn't warp at all, unless your patch is like this big and you're welding it to something really thick. But anytime you're doing sheet metal to sheet metal, it's going to warp, it's going to move a little bit, but hopefully some of these tips will help you get to a point where you can minimize the amount of warpage and shrinkage in your part, and keep it easier for you to sand and then hammer and dolly your panel to be able to have that nice metal finish look. So we'll cover metal finishing in another video, but for now, this is this week's Trick Tip Tuesday. Send us an email, tips@Trick-Tools.com, and we'll see you next week.